Introduction. In the intricate tapestry of ancient Greek thought, Zeno of Elea, a pre-Socratic philosopher and mathematician, holds a distinctive place. Born around 490 BCE in the vibrant Greek colony of Elea, located in modern-day Italy, Zeno gained renown for his exploration of paradoxes that not only challenged conventional understanding, but also ignited philosophical debates and left an indelible mark on mathematical thought over the centuries. Life and historical context. Zeno's life unfolded amid a period of profound intellectual ferment in ancient Greece. Elea, a thriving hub of intellectual activity, provided the fertile ground for the growth of philosophical thought. Zeno, a disciple of the radical philosopher Parmenides, embarked on intellectual endeavors that sought to challenge and refine prevailing beliefs, particularly those concerning the concept of motion and the nature of change. Zeno's paradoxes. Zeno's most enduring contributions take the form of paradoxes, each addressing different facets of motion and infinity. Far from being mere mathematical puzzles, these paradoxes were philosophical inquiries aimed at probing the very fabric of reality and our understanding of change. Four of his notable paradoxes stand out. 1. Achilles and the tortoise paradox. In this paradox, the swift Achilles races a slower tortoise but is deemed incapable of overtaking it despite giving the tortoise a head start. Zeno argued that infinite divisibility prevents Achilles from completing an infinite number of steps to reach his destination. 2. Dichotomy. Paradox. Focusing on an infinite series of divisions, the dichotomy paradox posits that to traverse from point A to point B, one must first cover half the distance, then half the remaining distance, and so on ad infinitum. Zeno questioned whether an infinite series of divisions could be traversed in a finite amount of time. 3. Arrow paradox. Zeno's arrow paradox delves into the nature of time and motion. If an arrow is in motion at any given instant, it must occupy a specific position. However, if time is composed of distinct moments, the arrow is motionless at each of these moments, challenging the idea of continuous motion. 4. Stadium paradox. The stadium paradox explores continuous change. Zeno proposed that in a stadium, a moving object traverses equal lengths in equal times. However, during each interval, the object is at rest, challenging the notion of continuous motion. While these paradoxes may appear perplexing, their purpose was to stimulate philosophical discourse and challenge prevailing notions about motion, space, and infinity. Contributions to mathematics. Zeno's paradoxes, deeply rooted in philosophical inquiries, had a profound impact on the development of mathematical thought, laying the groundwork for later mathematicians to grapple with intricate ideas. 1. Foundations of calculus. Zeno's paradoxes foreshadowed challenges in the development of calculus. Concepts like infinite series, limits, and converging to a point were essential for later formulations by figures like Newton and Leibniz. 2. Exploration of infinity. Zeno's paradoxes forced mathematicians to confront the complexities of infinity. The dichotomy paradox, with its infinite series of divisions, became crucial in understanding mathematical limits and convergent series. 3. Philosophical influence on mathematics. Zeno's work exemplifies the interconnectedness of philosophy and mathematics in ancient Greece. His inquiries into the nature of motion and the infinite inspired mathematicians and philosophers to grapple with fundamental questions about reality, legacy, and influence. Despite the ancient origins of Zeno's paradoxes, their impact endures, remaining subjects of study and debate in philosophy and mathematics. 1. Post-Aristotelian influence. After Zeno, Aristotle engaged with his paradoxes, offering solutions and distinctions that influenced later thinkers. The debate persisted through the Hellenistic period and into the Roman era. 2. Medieval and Renaissance reception. Zeno's paradoxes were revived and debated during the medieval and Renaissance periods. Scholars like Thomas Aquinas grappled with these ideas, and Zeno's influence on the understanding of motion and infinity persisted. 3. Modern reinterpretation. In the 19th and 20th centuries, Zeno's paradoxes received renewed attention with the advent of set theory, calculus, and mathematical logic. Mathematicians and philosophers, including Bertrand Russell and Alfred North Whitehead, engaged with Zeno's paradoxes in the context of these advancements.